Example 10. For a certain product, cost C and revenue R are given as follows, where X is the number of units sold in hundreds. The cost, C squared equals X squared plus 94X plus 58. The revenue, 896 times X minus 5 quantity squared plus 22R squared equals 17,248. The first thing we're asked to do is find the marginal cost, that is the derivative of C with respect to X at X equals 5. Now notice here that this function is not solved for C, so every time we take the derivative of a term with a C variable, we have to apply the chain rule and write in dc dx. So I'm going to take the derivative with respect to X of C squared, the derivative with respect to X of X squared, the derivative with respect to X of 94 X to the 1/2. I'll go ahead and write my square root as X to the 1/2, and the derivative with respect to X of a constant 58. So the derivative with respect to X of C squared would be 2 times C and the derivative of C with respect to X, since we don't know C in terms of X. The derivative with respect to X of X squared will simply be 2X. The derivative with respect to X of 94X to the 1/2 will be 94 times the power 1/2 and the base to the power minus 1, which is 1/2 minus 1, and the derivative of a constant is going to be 0. So I have 2C, derivative of C with respect to X, equals 2X, plus half of 94 is 47, and then X to the negative 1/2, because 1/2 minus 1 is negative 1/2. So this is going to be over the square root of X, right? Because this would be 47 X to the negative 1/2. So that's 47 over X to the 1/2. And the 1/2 power means square root. And we're going to have to evaluate it. So it's best to just go ahead and put in the square root notation again. And then plus 0. Solving this for dc dx, which is what they ask us to find, the derivative of cost with respect to X, I'm going to divide both sides by 2c. Now on the right-hand side, I should divide each term by 2c. So 2c here and 2c here. So 2x over 2c is going to be x divided by c, plus anytime you have a fraction over a whole number. So look, this is over 1 in the denominator. That 2c is going to end up in the denominator. So it's 47 over 2c, the square root of x. So that's my derivative of c with respect to x. And then they asked us to find this at x equals 5. Okay, so we've got to find this at x equals 5. But wait a minute, we have a c in there. Well, we can find the value of c because we know the formula for c squared. We were given c squared is x squared plus 94 square root of x plus 58. So c would normally be the plus and minus square root of this, but because we're talking about costs, we're only concerned with the positive one. So we can eliminate the negative one and just look at the positive of this expression where x is 5. So 5 squared plus 94 times the square root of 5 plus 58. And notice in the instructions that this says Do not round until the final answer. Well, since they want us to round to 2 decimal places, nearest hundredth, what we can do is we can go multiple places past the decimal, and then we'll be safe to get 2 places accurately. If I work this all the way out, 25 and 58, see there's a 25 here, plus 94 square root of 5, 58. I can add the 25 and the 58. That's going to give me 83 plus 94 square root of 5. So I'll do the inside first using my calculator. 83 plus 94 square root of 5 comes out to about 293.1904. 4 decimal places should be accurate enough. And when I take the square root of that, I get a value that's approximately 17.123. So that's the value I have to use for C in my formula for the derivative of C with respect to x. So I'm going to place my x value of 5 and my C value of 17.123. So 5 divided by 17.123 plus 47 divided by 2 times 17.123 times the square root of 5, and yeah, it gets a little messy here. And so we're going to get an approximate value to 2 places. So when I divide 5 by 17.123, I get 0.292, and then it's 0.004. So probably can go to 0.292 and still be accurate to what my math lab wants. And then that's going to be 47 divided by, and I'll get a value for my denominator, 2 times 17.123 times second x squared 5. That's about 76.5763. So I've got 0.292 plus 47 divided by 76.5763, 0.613, and then there's another 7 after that. And I add those together, 0.61377 plus 0.292, and I get 0.90577. And remember, it said to the nearest hundredth, that's 2 places. And so that's 0.91. Now let's explore what that means. This is dc dx. So this is the change in the cost. It's our cost formula, the marginal cost, the change in the cost when x is 5. And notice x is the number of units sold in hundreds. So even though they didn't ask us to interpret this, let's go ahead and do that. When 500, not 5, but hundreds, 500 units are sold, costs are increasing at 0.91 cents per unit. That would be our interpretation. Now let's look at part B. Our revenue function was given as 896 times x minus 5 quantity squared plus 22 r to the second equals 17,248. They want us to find the derivative of r with respect to x. And so when we take the derivative of this r term, we're going to have to write dr dx because we don't know what r is in terms of x. So we're going to take our derivative with respect to x of 896 x minus 5 to the second. We're going to use the power rule on that one. Plus the derivative with respect to x of 22r squared equals the derivative with respect to x, 17,248. That's a constant, so that derivative will be 0. But just in case that's not a constant, make sure you take the derivative of that right-hand side as well. So the first term is going to be 896, a constant, times the power, 2, times the base to the power minus 1. And then I'll go ahead and do the chain rule inside by taking the derivative of the base, but it turns out to be 1 this time. But it's always important when you have a base that has more than one term in there, like x minus 5, or if it has a 3x squared or some other base that you could take the derivative of that, you apply the chain rule. Plus, this is going to be 44r, and then the derivative of the base is going to be dr dx. And now I need to simplify and solve for dr dx because that's what they're asking me to find. So I get 1,738 times x minus 5. I just multiply the 896 times 2 plus 44r dr dx equals 0. And I need to solve it for dr dx. So I'm going to go ahead and distribute 1738 times x is 1738x minus 1738 times 5 is 8690 plus 44r, derivative of r with respect to x. And remember, I need to isolate that dr dx. So I need to move these two terms by doing the opposite signs on the other side. So 44r, derivative of r with respect to x, equals 8690 positive minus 1738x, because they're going to be opposite sides. And now I need to divide both sides by 44r. And here I'll just divide the whole side by 44r. And so dr dx is 8,690 minus 1738x divided by 44r. Now they gave me a value of x equals 5. My issue is I don't know what r is, but I have a formula for r squared, or I can at least find r squared using this original formula for revenue. So I'll say 896, 5 minus 5 squared. Remember, there's an x minus 5 and x is 5, plus 22r squared equals 17,248. Well, this is going to be 0 because 5 minus 5 is 0 and 896 times 0 is 0. So I have 22r squared equals 17,248. Divide by 22, both sides. R squared is 784. So R is 28. Now it would be positive and negative 28, but because it's revenue, my revenue is not going to be negative. It's going to be at least 0. Okay? And now that I know what R is and I know what X is, I can find the change in the revenue with respect to the units sold. It's going to be 8690 minus 1738 times 5 divided by 44 times 28. So that's 8690 minus 1738 times 5 is actually 0. And 44 times 28 is a little bit irrelevant, but I'll go ahead and do it. 1232. So it's 0. So there is no change in revenue at 500 units sold.